Hi, this is Geophil Sonja Philipp from Germany. Today I would like to talk a little bit about earthquake and fault zones or faults. As you may know, there are three types of faults. The faults are large-scale shear fractures. That means that we have a movement, a displacement parallel to the fault plane, to the fracture plane. So there are three types. That is so-called normal fault. That does not mean that they are more common. It's just from the part of southern England where the fault zones were first discovered or described. They were more common. That's why they were called normal faults. So the hanging wall, the block above the fault plane is moving downwards. That is what we call a normal fault. That is, for example, in a graben structure, we have them very common. The opposite movement is that the hanging wall is moving upwards, is called a reverse fault, or if it's very low angle and very long displacement, it's called a thrust. And the third type is called a strike-slip fault. That means that the movement is in direction of strike of the fault. That's why they are called strike-slip. In English, we can combine normal and reverse fault also to dip-slip fault, because the movement is in direction of dip of the fault. There are, of course, also combinations that are called oblique faults that are combining strike and dip-slip movement, so like that. You may know that the earthquakes have commonly magnitude. That is very common to call them like M6 earthquakes or something. This is the magnitude scale is giving an indication of the amplitude of the seismometer measured in the seismogram. That gives an indication of the total energy that is set free during an earthquake, and the magnitude is a logarithmic scale. That means that a decadic logarithm. So that means that one magnitude more means there is 10 times higher amplitude in the seismogram. Sorry for that. And it also means that there is about 30 times more energy set free during an earthquake. That means that 2 magnitudes more equals to about 1,000 times more energy that is set free. That means that there is the magnitude scale has no definite end, but there is, in praxis, there is no possibility of an earthquake that has a very, very high magnitude, because that would just rupture the entire Earth. So the largest earthquake that was measured was the Chile earthquake in 1960 that had a magnitude of 9.5. And that meant that the movement was on a fault zone that was around 1,000 kilometers long. So that is quite a long fault zone that is necessary to have such a slip on a fault plane. You cannot have an earthquake of a large magnitude when you cannot have this large movement along a fault zone. So the movement was about 20 meters, but along a line or fault line that was about 1,000 kilometers long. So the maximum movement was 20 meters. That is quite a lot. I don't want to experience that, in fact. If there is no fault zone of such a length, we don't need to be worried about such a large earthquake. That's for Germany, for example, we don't need to be afraid of a large-scale earthquake here, because we simply do not have any fault that is of this length. There are also other possibilities of measuring the intensity of an earthquake. For example, the Mercalli scale gives the intensity of an earthquake that just maps what is destroyed and where was it felt. But this also depends, of course, what type of building structures we have And also the destruction of an earthquake also depends on how deep was with this earthquake and what kind of rocks are there. So is it shaking very much or not? An earthquake in general happens when the fault plane is moving abruptly, or the fault plane is moving abruptly. You know about plate tectonics, I guess. So the plates are moving more or less continuously, but the lithosphere is elastic, and so there's stress building up in the lithosphere, and there is friction between the different types of rocks on the fault plane. There is friction. So an earthquake happens when there is sudden movement along a fault plane. That was for today. If you have any questions, feel free to place them into the comments. I will answer them later. I see that there are watching some people. It's very nice, and thank you for your likes already. In the next week, I'm planning to talk a little bit about the complex structure of fault zones. They are so-called hydromechanical structure, because this is important very much for fluid flow and for my field of expertise. That's mainly fluid flow in geothermal reservoirs. It's a very important topic. So thanks for watching and have a nice day. Bye.